Okay, so in this video, we are going to look at evaluating the effectiveness of the link prediction techniques. So you should have seen this even in the machine learning course, that when you're doing some prediction, we could come across these four things called true positives, true negatives, false positives, and false negatives. Okay, let us see the definition and then look at the performance metrics. So true positive, indicate that using TP is the scenario where you are predicting a link that is indeed part of the graph. Okay, before I do this, let me go through what we're going to do. So we are going to have, you're going to be given a graph, so I call this actual graph. And let us say I'm going to remove 3 links from this graph. So I'm going to just randomly remove 3 links from this graph. And I'm going to predict 3 links using each of the link prediction techniques. So then, so let us say this is what it is. So this is actual graph, and these are the links that are predicted. And as I said before, in case of a tie, we could say more than one link, whatever the number of links that are in a tie, could be predicted. So what we are going to now do is compare the actual graph with what is called a predicted graph and come up with these values for these metrics. Okay. So let us see the definitions and then we'll come back to this result and come up with those measures. So true positive means predicting a link that is indeed part of the graph. So true negative means you are not predicting a link that is not part of a graph. So there is a node pair which is not supposed to have a link between them, and you're not predicting that they're going to have a link. So you're predicting basically then they're not going to have a link. Okay. Then false positive. So true positives and true negatives are the good things, because true positive you are predicting link that was there, so that's fine, it's good. Then true negative means you are not predicting a link that is not there, that's good too. Now false positive, it's also called type 1 error, means you are predicting a link between a node pair that really doesn't have a link between them in the graph. Okay, so there is a node pair that does not have a link between them in the graph, and you're predicting they will have a link. So that's a true negative. Sorry, that's a false positive. Okay. Now false negative means that's a type 2 error. Means there is a link between a node pair in a graph, and you are predicting that they're not going to have a link. So that means you can also say like what I mentioned here. So if you are allowed to predict only a certain number of links, you indeed end up not predicting a link that is part of the graph. Okay. So that is something kind of more serious than a false positive, because in a false positive there is you are simply predicting a link between a node pair that shouldn't have a link. Okay, it's not as erroneous or as serious as not predicting a link between node pair that is supposed to have a link. So false negative is a very serious error. So you should try to avoid given the two. If you could have a type 1 error, that's okay, but you should not have a type 2 error as much as possible. Okay, so it is a type 2 error that we should try to reduce. And if you cannot avoid a type 1 error, that is okay. Okay, so given the two errors, which one is something that you should avoid and which one is something that you should not avoid? So which one is something that it's okay to have, you can say like that. So it's okay to have a type 1 error, but not okay to have a type 2 error. Okay, so now let us look at the result of this link prediction technique. We are going to go through the process, but let me go through the final solution and basically illustrate how to come up with the values for true positives, false positives, and false negatives. So you're not going to really measure true negatives in this case, because true negatives means you are not predicting a link that is not part of the graph. That's like you are going to have several possible node pairs. So If you do that for a small analysis like this where you're predicting only 3 links, the number of true negatives is going to dominate too much. So we are going to completely avoid true negatives. So we're going to measure only true positives, false positives and false negatives. Okay. Alright, so even though we removed only 3 links, we end up predicting 4 links because we ended up having a tie. So ended up telling there could be 4 links. Okay, alright. Okay, so you see these are the ones in red are the 4 predicted links. Okay, now among these 4 predicted links, the link between 4 5 is actually the one that really exists in the graph. So the true positives is just 1 because true positive means predicting a link that is actually there. So we predicted a link that is actually there, 4 5. Then you see so among the 4 links, only one of them existed really in the graph. So the other 3 does not really exist in the graph. So you are predicting 3 links, the 2 5, 2 7 and 2 6. Those 3 links does not really exist in the graph. So that is called a false positive. Predicting something that is not there is called false positive. Then there are 2 links that existed in the actual graph, which are this 1 5 and 1 2. Right, so 1 5 and 1 2 were there in the actual graph, but they are not predicted here. 1 5 and 1 2 are not predicted. So that is called a false negative. So not predicting a link that is actually there is a false negative. So as I said, what we are going to do is, given this actual graph, I am going to remove 3 links. So in this case, the 3 links that I removed are 4 5, 1 2 and 1 5. So I'm going to see whether how many links I predict or what links I predict. So I really ended up predicting 4 links, and only one of these 4 links really existed in the graph. So that's true positive, and the other 3 links does not really exist in the graph. So that is a false positive. And these 2 links 1 2 and 1 5 that actually exist in the graph are not predicted to exist. So that means this is a false negative. Okay, so not predicting something that actually exists is a false negative. Okay, so once we know how to measure these 4 measures, especially in our case the true positives, false positives and false negatives, we can come up with these performance metrics. Again, they are not, as you can see, they are not involving true negatives. So true negatives, we typically don't use it. Okay, so there's this measure called critical success index is the ratio of the true positives divided by true positives plus false positives plus false negatives. So basically, the sum of these 3, true positives plus false negatives, is basically the 3 things that you are measuring, right? So what fraction of this is true positives? So you would like to have this 100% or 1, the ratio. Now the precision means what proportion of the predicted links actually existed in the graph. So the predicted links is a sum of true positives and false positives. Okay, so the ratio of true positives divided by true positives plus false positives, because true positives plus false positives are actual number of predicted links, and what proportion of these predicted links actually existed in the graph. So you should have true positives divided by true positives plus false positives. Then recall is the proportion of the links that are there and identified right way. So that is true positives divided by true positives plus false negatives. So true positives plus false negatives is the actual links that are there, and what proportion of these actual links you predicted rightly. So that is true positives. So it's called recall. So these are the 3 things we will be measuring, and we would like all the 3 to be closer to 1. Okay, so let me go through this example. So we have true positives to be 1, false positives to be 3, and false negatives to be 2. So critical success index is true positives divided by true positives plus false positives plus false negatives. So it's going to be 1 divided by 1 plus 3 plus 2. So it's 1 over 6, which is 0.167. So it could range from 0 to 1, and we have 0.167 as a critical success index for this technique for this particular graph. Now precision is what proportion of the links you are predicting actually exist. That's what precision means. So that is true positives divided by true positives plus false positives. So true positives plus false positives, 1 plus 3 is the number of links you are predicting. So 1 plus 3, 4 links you are predicting. What proportion of these 4 links actually existed in this graph? So that is 1 over 4, which is 0.25. And recall is true positives divided by true positives plus false negatives. So true positives plus false negatives is the actual number of links in the graph that are going to be tested for prediction. And among those links that are going to be tested for prediction, what fraction of the links you are predicting rightly? So that is true positives divided by true positives plus true false negatives. So in this case, true positives plus false negatives is 1 plus 2, 3. So 3 links are up for testing. You're going to test whether you're going to be able to predict those 3 links. And you're predicting here only one of these 3 links rightly. So 1 over 3, 0.33 is recall. So you would try to maximize all these 3 things, performance metrics. Okay, that will stop this, and we'll go through examples in detail in another video.